In Lab 2 Part D, we learn how to georeference and how to digitize. That means we learn how to take a picture and give it a georeference to say where on the ground that picture actually is. And then we learn how to edit or create shapefiles so we can create features ourselves, which is pretty cool. It opens up all kinds of possibilities. In talking these three through a little bit, you'll find that neither of these is exactly rocket science, and so my guess is you'll find it fairly straightforward to walk through the steps of this lab. I'll show you a few things that are potential points of confusion here, but my guess is you'll find this pretty straightforward. The starting point I want you to notice for me here is I opened a new project without a template, so it's just what I get when I do that. I have inserted a map, and I have opened Catalog Pane so that I can look at my data. In Catalog Pane, then, I'm opening up my 286 folder. I just go straight to that folder and everything is in it, so I usually am able to find what I'm looking for. In this case, we're going to start out by looking at the spatial properties of the files that we're working with. In Lab 2D, what you're going to do is open up the merged line work file and the buildings file that you worked with before. The instructions of the lab have you do this in a slightly different order than I'm about to do, because the instructions don't suggest that you first inspect your data. I do. And so in this case, what I'm going to do first is take a look at the merged line work file. I'm going to right click on that, and I'm going to look at the properties, particularly the spatial reference. And here it's telling me that the spatial reference is the North American datum of 1983. That is what we call a geodetic datum. It is fundamentally a map of, or it's a mathematical model of the world that uses the geodetic reference system of 1980, GRS-80. So it gives you the semi-major and semi-minor axes of those two things in meters, basically saying how far is it from the equator to the center of the Earth in this mathematical model, and how far is it from the pole to the center of the Earth. So imagine what they're doing is drawing an ellipse and then rotating that ellipse to create a 3D ellipsoid. This is a very commonly used datum. This is the datum that we use, that most public map-making agencies use in the United States. So if you download a map from the city of Baltimore, Baltimore County, or the state of Maryland, chances are it will be in NAD 83. It's just very commonly used. Other datum that we've seen this semester, the World Geodetic Survey of 1984, WGS-84, which is the datum that the Global Positioning System uses, and so it's more and more commonly being used. You can kind of think of it as a potential universal datum, but for now, a lot of agencies still use NAD 83 because it's expensive to transition things to something else. I just want you to see here that this is a geographic coordinate system, meaning that things are being measured in degrees. In other words, what we're looking at here is references to things on the surface of a spheroid, an ellipsoid. By way of contrast, if you look at buildings, you'll see that under the spatial reference, it is also in the North American datum of 1983. So the starting point for this file is the North American datum of 1983. So it uses the same ellipsoid model to locate things. So these two files are fundamentally consistent. But this one is in a projected coordinate system. So it took those coordinates from that datum and it stretched them out into 2 dimensions using the state plane system. We'll talk more about how this works, but the effect of that is that if you scroll down here, you'll see that the unit is not angular. It's not measuring things in degrees. It's measuring things in feet. And so when you measure a distance using the state plane, it'll tell you, okay, so how many feet is it from point A to point B? North American datum of 1983, because it's a geographic coordinate system, will tell you how many degrees, or some fraction of a degree from one location to another. So in a lot of ways, this is a more intuitive coordinate reference system to use. Like I said, we'll talk more about this. I just want to point out that these are fundamentally consistent. ARC is smart about this, and so it knows if both of them are in NAD 83, we can switch from one to the other. These work and play well together. We don't have to transform anything to put them both into a map, which is very convenient. The last thing I want to show you is a file that we're going to be working with in the lab. In this case, I'm having you work with this image of UMBC, of the UMBC campus from 2017. I'm actually going to use it as an example here, UMBC from 1996, just because I like to work with something different. I like to have at least one thing that I demo be something you're not working with. That is, nonetheless, if you want to find a different aerial image and georeference it, it's fine with me for the purposes of this assignment. I just want you to see how it works. Now, if we look at the spatial properties of the file you're working with, you'll see that when we look at the spatial reference, it says unknown. This is just a picture of the ground. We see where it is, we know where it is, but the computer just sees it as a picture. It's just an image. It knows how to open images, but it doesn't know where to put it. Not yet. And the same goes for the image I'm working with. It is just an unspatially referenced picture of the ground. So what I'm going to do is open that buildings shapefile first. First, I'm going to take a look at the spatial reference, by the way, of the map that we're working with. And you'll see that when I insert a new map, as we've seen before, the coordinate reference system is WGS84 Web Mercator. So I mentioned that WGS84 is a different datum. It's a different basic starting point for referencing things. And in this case, it's a projected version of that. We could look at more of the detail. I just want to point out that there is a default projection, a default coordinate referencing system being used when you open up any new map. That said, if you drag a file into the new map, like in this case I'm going to drag buildings, and then look at the coordinate reference system for the map again, you'll see now it is in state plane. So the first file that I drag into a new project establishes the data, establishes the coordinate reference system being used by that map. And to the extent the program can do it automatically, it'll take things that aren't exactly like that, like the merged line work, and figure out where to put it. And so when I take that UMBC picture and drag it into the view, the program goes, wait, where does that belong? And so if I zoom way out, I don't see that map or that image anywhere. It isn't showing up. Why not? Because it's not referenced anywhere. It's just sort of hanging out somewhere totally different. It is not georeferenced. And so if I zoom to this layer, I can get that picture shown, but that picture doesn't have any spatial properties. And so it isn't part of my other map. So if I zoom back to the other layer, I'll just see the image is nowhere to be found. Now what we're going to do then is tell the program where exactly this image belongs. And we're going to do that by opening up some georeferencing tools. We do that by starting with that image. And you'll see when I click on that, I can see the imagery tab show up in the menu here. And that allows me to do a couple things. What I'm first going to do is click georeference. I'm going to tell it that I'm going to figure out where that image should be on our map. We don't really explain this, but there's a tool called Auto Apply, and I just want to make sure it's not selected. Right now it seems to be selected, so I'm just clicking that to deselect it. Won't really talk about what that means. And now I'm going to fit this picture to the screen. So I'm basically saying that picture, we don't know where on the surface of the Earth it should be, but let's fit it to this image so I can look at these two things at the same time. So it's going to take that image and stretch it out over the screen. So I'll say fit to display. And we see the picture just kind of show up wherever it kind of shows up. And the idea here is we're going to tell, one step at a time, the program where that picture should be. We're going to do that by finding shapes that we have confidence in and assigning what we call control points to locations in the image where we can say, okay, there's the corner of a building, or there's something prominent that I can see in my reference data. In this case, the reference data we're working with is those buildings and those roads, so we can kind of align things using those. Now the idea with control points, and I'm going to click add control points here, is we're looking for some location on the image that we can find on our shapefile. That's kind of easy to do because we're familiar with the various buildings around here. And I'm just going to zoom in and find the corner of Sondheim Hall. Now, that's a little harder than you might imagine just because the image is kind of granular. There are shadows, but I'm going to suppose that the corner of Sondheim Hall is right about here in the image. And what I'm doing is finding a corresponding location in the shapefile, if I can get to it. And if I zoom in, I'm going to say that that corner, right about there, in the shapefile, corresponds to that location in the map. And you can see the image gets moved over, so it sort of aligns itself where it thinks it should be now, based on what I've shown it. And you can see it's far from perfect, but the idea is the more of these control points I add, the more I'll be able to sort of contort the image to fit what I'm seeing. Now, Sondheim's sort of on one edge of campus, and so what I'm going to do is zoom out here and find something a little farther away, like, say, these smaller structures. And if I need to, I can go to Map and click Explore, and that allows me to then pan around the image a little bit so I can get things where I need them. So I'll go back to Add Control Points, click on the GeoReference tab, and return. And incidentally, at any point, I can take a look at the control points that I've added and analyze them a little bit by opening up the control point table. So you can see this is telling me from the image where is the point I'm placing, and then on the map where is it. And it, on the basis of a few of these, will give me some overall measurement of my error, like by how well am I doing, in other words, at georeferencing this image. But we'll leave that for a moment. In this case, I'm going to find another location on the map, on the image. I'm going to find the corner of, let's say, the roof of this house, or this structure here, and find the corresponding location on the shapefile, the corner of this thing. And when I add this additional control point, you see it gets aligned a little bit better. Not perfectly, mind you, but better. Now, just a couple tips when you're doing this. It can be a common mistake to click around and add points randomly. Basic rule of thumb, start with the image and then click on the corresponding location on the map. You're clicking twice, in other words, on the map. It's good to move things around so that you can see what you're doing while you do it. If you need to, you can click on map and pan around a little bit and then go back to georeference, add control points, and you can move things around. If you get nervous and start clicking at random, remember you can always go to the control point table and you can right-click on one of these and delete them if you want. So you can get rid of, this is the delete selected, you can delete all the control points if you feel like you need to start over. So if at any point you feel like, okay, things are getting out of control, just start completely over. In fact, in creating this video, I started over a few times just because that's how it works when you're shooting video. Now what you're going to want to do is zoom out and add a few more control points. For the purposes of this demonstration, I'm going to leave that alone. And I'll just suggest the more control points you add, the better your rectification becomes. And the more you spread them out, go from all over campus, different locations, the better it's going to align overall with that image. One way of measuring your success, of course, is to take a look at how far away your points are from the locations on the ground that you're trying to reference. And you can't perfectly place them, but it can give you a measurement of how off it is by